So suppose we have this model and we now want to add in the ability for agents to communicate infection to each other. Thus far, we don't have any representation of that. We have fixed rates or times in particular states, and we say infectious, we say exposed, but there's nothing that really indeed, no mechanisms associated with communication of infection here. It can be the very definition of a communicable disease, that from person to person, if my likelihood of getting the disease is contingent on whether there's others with the disease nearby, right? And we may say infectious, but that's not really borne out by this. The mechanisms of infection are not here. Whether or not, two people, a given person's likelihood of being becoming infectious is independent of their neighbors. They're all like ships in the night, passing like ships in the night. There's no interaction between them. And for an agent-based model, even more so than other individual level traditions like microsimulation, the real emphasis is on agent-agent interaction and agent-environment interaction. Here we just don't have that. So let us bend ourselves to this task of getting in place communication of infection, if we may. Okay, great. Okay, so we only need to do a couple of things here. So we want to add communication of infection to this model. A couple of things we need to do. First thing is, we're going to need to make it so that if a person is infectious, they expose others to that infection. And the way in which we're going to do that is that each of these people is placed right now in a network, and the way in which they expose others is by reaching out and touching those others. And how do they touch those others? How do they influence those others? How do they sort of engage in interaction with the others through a message? So they're going to send the others a message. Now, messages can serve many purposes. Just one of them is communication of pathogen. That's just one. I mean, they can communicate information, they can communicate influence, they can communicate spread of innovation, communicate tendency to certain types of risk behavior, communicate all sorts of ways of influencing, say, one agent influencing another. In this case, it will be exposure to pathogen or exposure to a potentially infecting dose of pathogen. So we're going to have agents expose others nearby them. Now, if it so happens that those agents that they expose are themselves susceptible, then they'll get infected. By contrast, if it turns out that those agents are not susceptible, but say already infected, it won't matter if we expose them. They're already infected. If they're recovered, it won't matter. If they're exposed, it won't matter. It's really, if we as an infective expose an agent who's susceptible, that message goes out to someone who's susceptible, then they will be infected, but not otherwise. Just bear that in mind. And all that logic will be on the receiver side. And that points us to another thing we need. We need, when we expose an agent here in the infectious state, if there's a susceptible agent specifically, and it receives that exposure, it will transition. So those are two things we need so far. One is a mechanism of exposure. One is a mechanism for the susceptibles to be influenced by that exposure to pathogen. if they are susceptible. If they're exposed, infectious, recovered, they're assumed to be not influenced by it. But there's one other thing. We're going to need to start with at least one agent infected. And there's many ways to handle that. We'll select one. Okay. So let's go about this. So first thing we're going to do is we are going to put in place, so I'm going to hit each of those in turn. We're going to put in place a mechanism of transmission. And this is going to require, so this is still going to be in the context of this state chart. It's only going to occur, well, in what state will people expose another to pathogen here? And which of these states will they expose another to pathogen? Anyone? Which particular state? It's one of the states. You want to pick? Which one? Michael is exactly right, as usual. It's in the infectious state. So we're going to go to the palette. We're going to go to transition, and we're going to drag in what looks like a strange transition. It'll be from this state to this state. Like that. Okay. How did I do that? Well, I dragged it in, and I like to drag it so one end of it only is there, and then I connect up the other end within it, and then I kind of like to position it so it has a certain breadth to it, so it's not invisible. But the truth is you can do it as you want, but it's easy to get it kind of weirdly crinkled up and kind of annoying. So, if you want to delete it and start over, that's fine. Okay. So this is going to be this is going to represent exposing people to infection. Okay. And we're going to make this a rate transition. It's going to occur at a certain rate on average. Think of someone coughing, something like that. They're going to bouts of coughs at a certain average rate, but we're not going to say it's every 1 minute on the minute. It's not going to be like the geyser in Yellowstone, which, Old Faithful, which goes off 10 minutes past the hour or whatever. And by the way, it's just showing us, we've been really neglecting an important part of modeling, which is communicating to stakeholders. And we haven't been really taking advantage of expressing our intentions clearly, visibly, as much as we could. Should really show it with the name here. I clicked here and drag it around, and the name shows we haven't really named this well. So let's name it well. Say exposure. Okay, exposure and transition, and I'll put it sort of next to it. Okay, so it's exposing people. Now, right now it says 1 per day. Really, ladies and gentlemen, we want this to be a parameter in main. Okay. Okay. So let's go down main, and let's drag in parameter, and this is going to be called contact rate, not contactee rate. Contactee rate. Okay. And maybe its default value will be 5.0 points per day. Okay. 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 So probably we should say I'm going to call it per day contact rate, or something like that, or daily contact rate. You could call it contacts per day. Maybe I'll call it contacts per day. How's that? You may wonder, like, why I'm spending so much time. Names matter. Names matter. Good names prevent bugs. Good names prevent misunderstandings. So I'm going to name it. I like spending time to be careful, judicious about my choice of things, and it heads off problems. I know that from 30 years, 32 years of building these models. Okay, context per day. Great. Okay. So now let's go to person, and we'll set this. And I'm going to say, okay, great. We're going to type contacts per day. What's the problem? What's the problem? What have I forgotten, ladies and gentlemen? What have I forgotten here? If I try to build this, I'll be unhappy. Why? Yeah, main dot. Darn right. Main dot. Main dot. Okay. There we go. Main dot because it lives in main. Here's main, and contacts per day live there. Do you see that? Okay, now you may wonder, what is this doing? I mean, this is kind of a weird thing, you may think. It's going from here to here. Well, the point is, while you're in this state, this thing fires. You never leave the state. You're just staying in it. It's just firing at this rate. Just firing, firing, firing. And you say, well, what's the use of it then? It's going from the state to its state, and it never leaves the state. I mean, what's the use of this weird construct? Well, the use is it's going to do something. And what is it going to do? It's going to expose other people. And how is it going to do it? I will show you that right now. Okay. We're going to go to this action. Action is what we're going to do when this happens. And in general, these things have these things. Remember, you have an action here. You have a guard, which, by the way, tells it like only transition under these cases. There's an action. There's an action. There's a thing to do when this fires. We took advantage of an action here when you came into here. When you entered this, do this. When you entered this, do this. Entered here, do this. But beyond that, you can have actions associated with the actual transition. We'll see that in a little bit. This is contacts per day. When this fires, when this triggers, we'll undertake an action. And what action will it be? Well, we're going to expose a neighbor. We're going to cough. Boom. We're imagining we're with one of our neighbors. Okay. So we're going to say send to random connected. That means send to one of my, randomly pick one of my neighbors with uniform probability, incidentally, and send them a message. What express message is going to be? Well, for now, I'm going to do something bad. I'm going to say the message is exposed. Don't do this at home, ladies. There's a better way to do it. We'll get to that, but I don't want to distract it. We'll come back to this. So send exposed like that. Exposed. And that will expose this neighbor. If I'm infected, I'll expose the neighbor. Okay. Okay, so we could do this, and we would expose a neighbor. And next, we could go and we can put in here a mechanism by which susceptibles, remember, I said 3 things are needed. 1, a method of exposing others. Number two, a way that susceptibles can be affected by that message, by that exposure, by that influence. Three, starting out someone who's infected. So we're putting each of those into place. We're done with one. We're done with sending them. So at this many contacts per day, we're going to send an exposure message. Next, we're going to go here, and we want susceptibles to be able to be influenced by messages. So instead of having a rate transition, we're going to have a message transition. This is asynchronous. It's going to be triggered by receipt of a message, ladies and gentlemen. It's only by receiving a message saying they're exposed that one of these people will transition. Okay. And we'll say unconditionally. We're not going to right now key it off the message type. And the action, well, the action is just going to be to go here. But we're gonna take advantage of this. I told you we're going to take advantage of it. And I'm going to say, I'm going to print something out. Let's say I was infected. Trace ln is a way to print something out. Print it out in that console. I'm going to say, I was infected. Who's I? This. Oh my gosh, this. Plus, that means it's going to put it together with a string, quote, and I'm going to put in a string. Was infected, exclamation point. And guess what we need after this? This is a command. It's saying, print this out, print it out. Boom. Saying, print it out. What do I need after this if it's a command?
Semicolon?
Semicolon is right, because it's saying, do it. Undertake this. It's not computing a value. Like if, for like this rate, we computed a value here. We computed a value here. We didn't need a semicolon there. We didn't need a value for this thing because we're just computing a value. When we back when we were in Maine and we were, drawing people's, Y value from uniform distribution or annual, we didn't need a semicolon because it wasn't a command. It was just computing a value. It was a formula, what's called an expression. Here we're actually saying, print this thing out. Okay, great. So that's all we need. It sends a message. Sends a message at this contact rate, and it gets the message saying that we're infected. So that's the second thing of the three that I said we needed. We needed, number one, a way for infectives to influence, to sort of enact a mechanism of influencing others. Second, we needed susceptibles to be susceptible to that mode of influence, as contrasted with exposed or infectious or recovered people who are, that they don't pay attention to the message. It's only if they're susceptible they're gonna go across you. There's no message transition to handle it if a recovered is exposed or an exposed person is exposed or an infectious. It's by virtue of that there is this out transition that susceptibles are uniquely susceptible to this being receipt of the message. So this one's sending it, and don't get confused here. This one's sending it. It's going to be some other agent, not them. It's going to be some other agent who might nearby them be susceptible. It happens to be located in the network, who might be in this state, and if they're in that state, boom, they're going to go over there. So those are two of the things. But the third one is we need at least one person to start, one person to start infected or start exposed. One person to start off, because after all, if you run it, there's going to be no one exposed at the beginning. Everyone's going to be susceptible, and no one's going to go on and going to go to exposed and become infection. No one's going to kick off the initial infection. So what are we going to do? What are we going to do? Well, there's many ways to handle this. One way is to divide people up into each of these. We could divide a certain fraction start infectious, certain fractions start exposed, certain fractions start susceptible, certain fractions start recovered. Another way is to start one, like get one going at first. Another way is to set a whole set of them going at once. These are all, readily done. I'm going to show this one where we'll start a single person off. The index, patient 0, a single person. So what are we going to do for that? Well, I'm going to introduce one construct. And normally I would save my model now and let you sync up. But this is just completing the thought, really. So I'm going to go to palette. I'm going to add what's called an event. An event's job in life is to schedule or to essentially establish a schedule of events. Could be one, it could be a whole series at periodic times, like once every month or once every week or once every day, really good for reporting, for example. Or it could be at a certain rate. And you can kind of choose, does it occur once or does it choose cyclically? For example, every one day, these, and you could set it to be a rate, for example. I'm going to set it to be a timeout. It occurs once at time 0. And I'm going to send a message of exposure to a randomly chosen person. That's what I'm going to do. That's what I'm going to do. I'm going to send it to a randomly chosen person. Okay. So there's, again, several ways to do this. There's actually one that's kind of the classic way to do it. And then there's one that's more general. So maybe I'm going to use send, okay? And you'll notice that send sends a message to a certain object. And in this case, I'm going to send it to a certain person. What is the message I'm going to send? I'm going to send exposed. Don't do this at home. Okay. I'm living on the edge by giving this explicitly as a string. If I misspelled it, here it would be it wouldn't be a problem, but in general, it can be a recipe for disaster. Like you spell it one time without this, and if you hard code that you're expected with the exclamation point, it won't find it. It's really picky and persnickety. You don't want that. You want it to be checked to make sure it's handled properly. And I'll show you a better way to do it in a minute, but I'm going to say exposed. Right now, it really doesn't matter. Whatever it is, it transition. It's unconditional. Okay, so back to the salt mine. So here we're going to say exposed. And what's the destination going to be? It's going to be a random person for that. I know several ways to do this, but I think you can actually just say random. Give me a random person from there. Okay. There's also this thing called random from, but I think we'll probably get it there. You can also say delivered to random agent inside. This is kind of what the spirit moves me to do right now. Okay. And this is a command. We're saying, do it, send this stinking message. Send the message exposed to a random person from the population. It's a command, so we need a semicolon. And in general, things and actions need semicolons because they're commands. Do this, do that, do that. There's no value being computed here. It's not like you're computing 3.1415926. No. You're not computing any value. You're taking action. You're doing something, and you're changing something, and so you needed semicolons between them. Yeah. Okay. So at the start of the model, it's 0 days, 0 hour. You're sending a message exposed to a random person in the population. And guess what that's going to do? Remember, all the population starts in what state? At the very start, they're all in what state? Can anyone say? People are starting at the start of the model in what state?
Susceptible.
Indeed, they started here. That's where they come in. They come in here. Now, as I said, I could show you ways to start them in many states, a certain fraction of them, but for now, they all come in here. So all of them are initially susceptible. So if here in Maine, here down Maine, I send a message exposed to a random susceptible. So I send them a message. What will happen to a susceptible when it gets a message? Guess what? Guess where it will go? That's a message transition. We'll go across it. Right? We should really call this, I mean, I feel so guilty. Call this infection. Call it infection. Call it for what it is, infection. There it is. And really here, we should call it, guilt is overflowing. We should call it like completing latency, something like that. Well, and drag it there. And this one, we should call it recovery, recovery. That's pretty good. And hey, come on. There. Okay. But our model is basically complete for that. So so at the start, except this name is horrible. Don't name it that. Call it initial infection event. Give it a name that reveals its intentions. Give it a name that's clear. If someone sees it, if a stakeholder sees it, they know what it means. It's not just one more mysterious thing. Oh, it's the initial infection. Okay, that's kind of weird, but okay. You know what it is in the future. Okay. So the initial infection at time 0, it will send a random person in the population an exposed message. Everyone in the population starts susceptible. So we know whoever gets it, whoever in the population is selected by that choosing a random person, they will get infected. They will go here in the fullness of time. They will become infectious. They will expose others. And in that state, they will send at a certain number of contacts per day, as given by the parameter main, they will send a message to their neighbor saying, you're exposed. So that very first person, that index patient 0, they're going to have all their neighbors infected. They're patient 0. By definition, they're the first. So all their neighbors will be infected if there are neighbors, if they're not super wealthy. And it will expose those neighbors, and then those neighbors will become infected. Those neighbors, if there are neighbors, they'd be susceptible, and then they carry on. So let's see what happens, shall we? And then I'll answer the question. Okay, so there we go. It spreads. It spreads. And it's almost dying out. Why didn't this person get infected? Anyone?
They're not part of a network.
The network started here and spread here, or burnt out here. This one's part of a network, but they're not part of that network where the infection started. So it never reached them. Same thing with these ones. Let's try it again. There we go. Okay, it spread throughout this, but nary did it reach this, right? Yeah. If we started with a larger population, let's say 200, here we go. There we go. And now it's a bigger network, and look, it's spreading, it's spreading. Uh-oh. It's spreading out here. Okay, even this one's going to be in the far-flung reaches. It's gonna be eventually exposed, and now we see, you know, it having spread throughout this component, and it's dying down now, although some are still infected, and it never reached this point because these were in a separate component. Now we have ourselves a little nice little elegant SEIR model, and I will name this version 6 now to start on version 6, and we will add it to the course site. Okay, I'm going to add version 5 there. It is up there for anyone who wants to grab it. Okay, so I covered a lot of ground there. I did 3 major things to simulate the spread of infection. People are already on networks. So the infectious people I had go at a certain contacts per day. They sent messages to their connections in the network. So maybe, for example, let's imagine that this person was the first person infected, patient 0. They were infected by Maine, by this thing here. It picked a random person and sent them an exposed message. By definition, you know, or by construction, everyone starts susceptible here. So whoever received that message, say this one, would be susceptible to the message. So it would go to exposed, and in the fullness of time, they become infectious. They become the first infectious. And now they would start to expose other people at a rate given by this contact rate here. And at that rate, they'd be sending messages to their neighbors. This person being the first infectious, if they have neighbors, all of them will be susceptible. So all their neighbors, when they were sent messages, would go down here and become infectious themselves, and the infection will spread and spread and spread. Now, eventually, you know, as it spreads, there's going to be some that get infected, which when they become finally infectious, they're going to have some neighbors who are already or no longer susceptible. So when they send that message, they're going to infect fewer people. And so the infection won't spread as quickly. And over time, there'll be fewer and fewer people still capable of being infected, and you will get it with sort of making less and less progress and spreading slower and slower. And at some point, the number of people per unit time who are recovering will exceed the number that are getting infected, and eventually it will die out. And you'll notice, because we said this was infected, you'll notice it's reporting person 41 was the very first person infected, who had an annual income of over $100,000. So that person wasn't actually like way down here. They were probably somewhere up here, something like that. And yet maybe they were this person or that person. And basically they kicked it off, and they infected someone of 82,000 and 4,000 and you know, maybe 122,000, et cetera. And it kept on spreading, and you know, it spread particularly in sort of poor areas of the population. It spread among many, and yeah, and eventually sort of ran its course here. Okay, so that's a full communicable disease model. Okay, as I said, I posted it. Any questions that I can answer about this? I demonstrated a lot of mechanism. What questions can I answer?
Could you sort of, I know you've been over this, but maybe explain again when you want to send the message from an infectious person, why the transition is within that state?
Mhm. Great question. So thank you for the question. The question was, why is this transition kind of weirdly in here? I'll try to approach it from a couple angles. Maybe one of them will resonate. Number one, exposing another is not going to cause an infectious person to become uninfectious or move themselves to another state. My coughing doesn't make me recover. It doesn't make me change state. So my coughing, I may cough, but it's not something which changes my state. It's not an action which changes my state. It's an action which affects other people, but it doesn't change my state. So it'd be kind of weird if this transition went to recovered, because like then it would say I cough and then I recover, right? Which would be strange. So it kind of makes sense in a certain way that this transition doesn't go somewhere else. It doesn't go to another state because it represents my exposing other people. That's one explanation. Another explanation is, well, while they are infectious, whilst they're in the state of infectiousness, we want them to be exposing others with a certain rate while they stay infectious. And, it'll occur in a certain number of contacts per day. Think of them coughing on an average, getting coughing bouts 5 times a day on average or whatever. And so we want that to occur. And, it'll be kind of elegant if in some ways we could put, like we had this event thing construct, it'd be kind of elegant if somehow we could put that in there and say, it's only active inside the state, but you can't do that. This is kind of your way of having something happen while they're inside the state, making something happen, on an ongoing basis. Here, it's happening with a certain rate stochastically, but it could also happen, every, if it was like needle sharing, that'd be kind of weird, but we're needle sharing twice a day, you want to make it a timeout, you could say it's 12 hours between needle shares or something like that. And they're needle sharing twice a day, and the fact that they're needle sharing doesn't make them recover from HIV/AIDS or something. So it would still be whilst within this state. It's occurring. It's an action like bouts of coughing or needle sharing or exposure with an STI to someone. That's not leading them to recover. Whilst they're in that state of infectiousness, they are exposing other people. And so this is just kind of a convenient way of saying, hey, it doesn't go from the state to another. This is going on while they're in that state. This is a process which is occurring. I don't know if that's satisfying, but those would be a couple ways of explaining it.
Yeah, I think that makes sense. Thanks.
Yeah. I will say that one thing I'm not showing you is something more advanced, which you'll sometimes see in some of the example models. It turns out like within these states, you can also have sub-state charts. So you can have like hierarchical state charts, so state charts embedded in state charts. And there can be kind of internal processes in those state charts too. And this is, I think, of kind of one kind of internal process. It's kind of the simplest internal process within this state. But you'll see, actually, you can have much more sophisticated processes involving transitions among substates, et cetera, which are possible. Yeah. How about other questions? Questions? I'm looking at the chat. Okay. Okay. Questions verbally? Okay. Great. Well, I think we'll finish up this with just one or two other sort of pieces, and then we'll actually begin another model where we'll move quickly and live light on the land. Maybe I'll stop this recording and we'll start another one.